Thanks for the email question. Most of these concepts are in the live sessions or the tutorial videos, so make sure that you're going through them first, and also make sure that you're doing the required textbook assignments so you get some practice with these. And if you don't have a textbook from your last school, make sure you contact me so that you can arrange to pick one up from Marion Graham Collegiate. So I'm going to take some of these sample questions just straight from our textbook. The particular example that you gave me in the email is from a quiz, so I can't help you out with that, but this should give you sort of the general process. And there's two ways that you can do it, and there's two ways that you are asked to do it on certain quizzes. And I'll show you how to take care of both of those here. So the first way, and the way that I normally do it, is you simplify equations so that they're in the form y equals. And oftentimes you're given equations that aren't in that form and you have to change them to that form. So this is just solving equations, which you've done, I'm sure, many times in your career so far in grades likely 7, 8. And obviously you're going to use them for the rest of your high school career too. So let's just take a look at a couple of these that aren't currently in that format, and we'll see if we can come up with a solution. So if we look at A, the equation they give us is 3x plus y equals 9. And that is that's going to be an oblique line because we've got both a y and an x. So it's not going to be vertical. It's not going to be horizontal. It's going to be some sort of angle line. And that, you said you're in 4.3. So that's the general scope of 4.3, is dealing with vertical lines where you only have x equals values, and then on the horizontal where you've only got y equals, and then you've got the oblique lines that have both x and y, such as this one. So how are we going to take this and make it into the form y equals? Because that's what we do for lines. We always want to get it as y equals as long as there is a y. If there isn't a y, then we know it's a vertical line. So we've got the y on the left side of the equation, which is generally where I like it, and it is positive, and there is no coefficient in front of it. So most of our steps are already completed. What we have to do is get everything that's not a y over to the other side of the equation. We have a positive 3x on the left that's got to go. So how do we remove a positive 3x? We do the opposite, which is subtract. And whatever we do to one side of the equation, we have to do to the other side as well. So we need to subtract 3x from both sides. The 3x minus 3x just cancels out to 0. So we can just cross that out, which just leaves us with a positive y on the left side. And on the other side, we have 9 minus 3x. I like to rewrite this because as we move forward in the class, you're going to find that we're always going to want to have things that are x squared first, then things that are x, and then constants at the end when we write our final answers. So I'm just going to quickly rewrite this, and all you need to do is just change the order of them and don't change the sign. So if I want the x's first, I'm going to say that's negative 3x, okay? And this is a positive 9, so I'm just going to make sure it's plus 9. So that's the form that you probably should be writing things in. If you were to graph this particular linear relation, okay, now you're going to make your graph, and you're obviously going to want to label things properly and whatnot, but this is just a quick idea. You're going to want to make a table when you're graphing, and then you're going to want to have x on the left side, and you're going to want to have y equals whatever your equation is, negative 3x plus 9 on the right side, and then you're going to pick some values to put in there in order to help you plot it on the graph. And I usually do 5 values. I usually start at negative 2, negative 1, 0, 1, 2, but you can pick whichever values you want in there. You definitely want to have at least 3. So if I look at negative 2, now it's just a matter of substituting that negative 2 into the equation for x and then finding out what y equals. So if I take this little chunk over here, I say 4x equals negative 2, I'm just going to write y equals negative 3, and then I'm going to substitute in the negative 2 for the x, and then plus 9. So y equals, order of operations, BEDMAS, right? Multiplication before addition. So negative 3 times negative 2 is going to be a positive 6, plus 9 at the end there, and that's going to be 15. So for the first line of your table, if x is negative 2, y is 15. Then for the next line, we have to do the same thing for x equals negative 1. So it's the exact same process, negative 3 times negative 1 this time, plus 9. So that's going to be positive 3 plus 9 is 12. And you can do these in your head after you kind of get better at doing substituting numbers in for x. And 0 is very easy because anything times 0 is just 0. So if y equals negative 3x and x is 0, that basically means y equals 0 plus 9, which is 9. Once you get to this point, you can see what's happening here, right? We've learned that in linear relations, we've learned this in 4.1 and 4.2. In linear relations, if you've got a pattern, it is indeed a linear relation, and we can see that the pattern here is -3. So every time that we go up 1 on the y side, we go down 3 on the x side. So we would expect that if we substitute in 1, our number should be 6, because it's 9 minus 3. So let's just sub it in quickly and just test that out for ourselves. So for x equals 0, x equals -1, my mistake. We've got, nope, +1. Or it did -1. So for x equals 1, we've got y equals -3, sub in the 1, and then plus 9. So that is -3 plus 9, which indeed does equal +6. So our pattern continues, which means it is a linear relationship. And then we don't even really need to do the 2. We just know it's going to be 3. So you've got a table of values. You rearranged your equation to make it y equals. You've made a nice table of values. And now you've got your x and y graph, and you can point things on the graph. Now, I don't have any scale on this. I don't have any numbers either way, but let's just say that -2 is going to be here, and +15 is going to be there, and then -1 is going to be here, and +12 is going to be there, and 0 is going to be there, 0 and 9 is going to be there. And when you finish filling in all these dots on your chart and you draw the line, the graph is going to look something like that. So that's using substitution. I'll just erase this stuff and maybe do one more from this list a little bit quicker, one that requires a little bit more work on the solving side, but it doesn't really require any more work on the table or the graphing. So let's take one that's got a coefficient in front of the variable, and you'll remember those terms, coefficients and exponents and whatnot, from Unit 2. So we're starting out with x minus 2y equals -6. So this one, we do have to do a little bit more work. First off, our y is negative right now. And secondly, there's a coefficient in front of it. You always want to get y by itself. So that's usually my first step. I'm going to get y's by itself. So that means getting rid of the x. The x is positive. So my first step is going to be subtract x from this side. And I'm going to do it from the other side too. Whatever you do to one side, you have to do the other. That cancels the x, which leaves me with -2y equals -6 minus x. Now I need to take care of the fact that I've got a -2 in front of my y, because I don't want -2y equals, I just want y equals. So in order to get rid of the coefficient and to make it positive, I have to divide, because this is multiplication, -2y is really -2 times y. I have to do the opposite of multiplication, which is division. So I have to divide this by 2, not by 2y, just by 2, because I want to leave the y there. Whatever I do to one side, I have to do to the other. So I have to divide every term on the other side by -2. And don't forget to do it for every term. Now, -2 divided by -2 is just 1. That's why we did it. So it's really 1y equals, and whenever we have 1y or -1y, we get rid of the 1. It's either just positive y or negative y. It really is 1y, but we just know in math that 1 times anything is just itself, so we don't include the 1. So on the other side, let's look at what we've got. We've got -6 divided by -2. That's a +3. Then we have a -x divided by a -2. Now, I can't divide x by 2. They're not like terms, so I have to leave it like that. However, it is a negative divided by a negative, which is going to give us positive. So I'm going to say positive x over 2. Now, that's a fraction, but you don't need to be scared of fractions anymore. Y equals, and I just rearranged this because I always like to have the x part first. So it's x over 2. That was positive, and then the 3 is positive as well. So x over 2 plus 3. Now I've got it in the form I wanted. I've got it in y equals form, which is what I need for my chart. When we make our table, our x still goes there, and our y equals x divided by 2 plus 3 goes over here. Now, we don't need to worry too much about the fraction, because we know x is just going to be replaced by a number in our table. But let's pick numbers that work really well with dividing by 2. So in this case, instead of using -2, 1, -1, 0, I'm going to go -4, -2, 0, 2, 4. And the only reason I'm doing that is because I know I need to divide it by 2, so I want to get nice numbers. I don't want to get decimals or fractions in my final answer over here. So let's start with the first one. If x is equal to -4, okay, the first one I picked on my table. Remember, you could have picked any values you wanted. I just picked -4 because it was convenient. For x equals -4, we just need to sub it in, right? Substitute it in. Y equals x is -4 divided by 2 plus 3. So now that's an easy expression to solve. Y equals -4 divided by 2 is going to be a -2 plus a +3. So y is going to equal a +1. So that wasn't so bad once we substituted a -4 in there. Now let's do it for x is equal to -2. Same process. Y equals, now it's -2 over 2 plus 3. -2 divided by 2 is just -1. And then plus 3 is just plus 3. So -1 plus 3, that's going to equal 2. And I think you can probably already see the pattern happening. Let's see if it continues with the 0. So if x equals 0, then y equals 0 divided by 2 plus 3. Well, 0 divided by 2 is just 0. So I don't even need to worry about that, which means all I'm left with is 3. So when x is 0, y is 3. You can see the pattern happening. It's +1 every time, which means now that I know what the pattern is, as long as I did the first couple correct, I could just fill in the blanks. So now I've got an x value and a y value, and I kind of look at an existing graph and see if those points are on any of the lines that are there, or I can draw it myself, right? So if this is the x and this is the y, again, I should have numbers and grids and whatnot, but I'll just give you a quick example. If x is -4 and y is 1, okay, let's just say that this is -4 for the x, and let's just say that that's 1. For -2, x is 2, so let's just say that's -2, and that is a positive y value of 2, so this would be -4. This would be -2, that's +2, so this would be a +1. Then we go to 0, which is right on the y-axis, and then this would have to be 3. So the line that we get, if we plot this graph on graph paper, is something that looks like that. So that's the way that I recommend doing them, and that's the process I recommend doing for them. If you follow that process every time and you know how to add, subtract, divide, and multiply, you should be okay. The other way that we can both build graphs and test values is by substituting. And we did do substituting before. This one, we don't change this into y equals. We just substitute for values and then solve for y. So we end up using the same process, but we don't do it right away so that it says y equals something. We kind of substitute in certain values. So they tell us exactly what values to sub in, okay? So we're going to need to do it 3 times. They gave us 3 values. So with x equals -4, then we just sub it into this equation right here. So 3 times -4 minus 2y equals 6. Now you see, we still need to solve for y. So we still really need to do the work we did before, but just instead of doing it ahead of time, we basically got to do it 3 times. That's why I like the other way better. All right, we've got enough information here to solve it, so let's just simplify it first. 3 times -4 is -12. Still minus 2y equals 6. Same process as before. I got to get the y by itself. I got to get rid of the -2, but I got to get the numbers worked out properly first. So I've got a minus 12 here. I got a positive 6 on the other side. I got to get rid of the 12, which means I have to bring it to the other side. So now there's no x in this one because we already substituted -4 in for x because they told us to. So that -4 is from there. So if I go -12 plus 12, that's 0. That was the whole point. And then I've got 6 plus 12 is 18. And now it's a nice easy solve here. I just divide by -2 on both sides, and I'm left with y equals -9. So that is 1 point. If x is -4, then y equals -9. Now let's look at the next one, which is x is 0. Zeros are usually super easy to work with. So now we've got the exact same equation, right? We always start with this equation. It's 3 times x, which is 0, minus 2y equals 6. Same process, except this time it's easy because 3 times 0 is just 0. So I can just cross that out. So I'm just -2y equals 6. -2, divide by -2, and we get left with y equals -3. So there's the second part. That one was nice and easy to solve. And then for x equals 4, okay, same process. 3, this time times +4 minus 2y equals 6. That is 12 minus 2y equals 6. Now we've got to subtract 12 from both sides. Okay, so it's very similar to the first one, but this time we have to subtract 12 instead of adding 12. So we get left with, well, I don't need to write the 0. Obviously, 12 minus 12 is 0. So I've still got -2y equals 6 minus 12 is -6. So now I still need to divide by -2 to get my y equals, and this time it's -6 divided by -2, and that's going to be a +3. So we substituted in those 3 values for x, and then we came up with 3 separate y values. At this point, now you can just go right to your chart again. I can delete this, you've seen this already. So at this point, I can just go right back to my chart, or my graph, and then I can just plug them in, right? So if x is -4, let's just say that this is -4 right there, which would make this +4. Let's say that this is, what are our y values? Okay, so let's just say that this is +5, and this is, say, +10, which means I have to have the same space on the bottom. So that's going to be -5, and that's going to be -10. And let's just put these points in about the right spot. You're going to be more exact, and you're going to be use rulers, but this is just a quick demonstration. So if x is -4, that's right here, and y is -9, that's going to be down here somewhere about right there. If x is 0, so x is 0 right here, and y is -3, it's going to be down here somewhere. And if x is +4, y is 3, it's going to be there somewhere. And you can see that makes a nice straight line because it is a linear relation, and it goes up like that. Make sure you put your arrowheads on both sides. So that's how you do it using substituting values. It's important to know both, but I think as you move forward in mathematics, you're going to be asked more to just simplify things in terms of y equals something. There you go. That's both ways. Again, make sure you're watching all the tutorial videos and the recordings of live sessions. They're all posted. And make sure you're doing the textbook practice questions before the quizzes and the practice for the unit exam. Have a nice day.